So for our work problems video, I'm actually going to start with another video that was made by a colleague of mine, and it's about 4.5 minutes. It's going to set up our problem, and this is an example of a work problem that we'll go over after this. So watch carefully and pay attention. Take notes if you can.
Suppose you decide to host a summer lemonade party for all of your friends. Not sure of what you need? You go to Google to see what's out there. After a couple minutes of searching, this is what you find. You decide you're going to model your entire party off of this picture, so you make a list of the things you're going to need. On that list, one of the most important things you decide is that you need to get a lemonade container. So where are you going to get one? Amazon, of course. This is the first one you stumble upon. It's $68.32, and it even comes with a leak-free stainless steel replacement spigot. Who would ever need that? I'm going to find a cheaper alternative. Upon further inspection, you stumble across this guy. $16.95, no replacement spigot. This would be the one. A few days later, your order arrives. You quickly notice one thing. They forgot to pack it correctly, and the spigot is now broken. Without enough time before your party, you have to do some investigating to see what you can do. With just a little bit of a mess, you determine that if you hold your finger over the spigot, your faucet's able to fill the container in just 3 minutes. However, when you let your finger go, the water drains out in 7 minutes. Now, how am I going to figure out how long it takes to fill if my finger's not there blocking the spigot? Running out of time, you decide maybe the best approach is just to test it out and see what happens. After just a few moments of doing this, you realize that if it takes that long to fill it, and it takes 7 minutes to drain it, it's going to take quite a while to figure this thing out. Maybe I should go at it with a mathematical approach. So, if I think about the problem, the area that I'm really focused on filling is just between this green line and this black line. The black being the top and the green being where the spigot is. The reason I don't need to worry about what's underneath is because that's never going to drain out. So let's think about our rates. The first thing I realize is that if it takes 3 minutes to fill, then I could say that it has a fill rate of 1/3. One of the reasons I can think about it this way is because that means I can fill one container in just 3 minutes. Now, what does this mean for my problem? Well, another way I could think about that rate of 1/3 is that if I divide my container up into 3 equal sections, each of those sections would represent roughly a minute. Because if it takes 3 minutes to fill the entire thing, that means it can fill 1/3 of the container, or 1/3 of the space, in just 1 minute. So, after 1 minute, we can see how our container would be 1/3 full. Now, if we repeat that process for 3 full minutes, it would make sense that our container would be filled all the way. Now that we realize and understand how long it takes to fill our jar, we have to also be aware of the fact that our jar is constantly losing water. So it's not all about just filling the jar full. Every minute that goes by, we fill the container what would be 1/3 if it wasn't losing any water, but since it's losing water, we see that our water line would be just below that 1/3 line. Now, how much it's actually below is what we're sitting there trying to figure out. We need to take into consideration our drain rate. If we use our fill rate and our drain rate together, then we would be creating what we would call a combined rate, which would actually help us solve the problem. So now, using what we've discussed about, figure out how long it would take us to fill the jar if it's constantly losing water.
So after watching that, I wonder if you might have an idea of how long it's going to take to fill the problem. Okay? So we look at the problem one more time. It says one faucet can fill a jug starting at the green line and making its way up to the black line in 3 minutes. The nozzle on the jug can empty in 7 minutes. If the nozzle is open when you begin filling the jug, how long will it take to fill from the green line to the black line? Well, one of the things that was noted in that is the fill rate. So our fill rate was 1/3. And remember that one container is filled in 3 minutes, right? That's how we get 1/3. Now, there's also a drain rate. And I'm wondering if you maybe thought of the drain rate after looking at the video. Well, if it took 7 minutes to drain the whole container, one container drains in 7 minutes. And you'll notice that's probably going to be a negative number, right? Or you could think of it as positive and subtract it, but it's the same idea. One container in 7 minutes. So if you think about this, right, if you say 1/3 is going to go up in a minute and you're taking away 1/7 every minute, right, we want it to equal one full container, right? And so there's got to be some unknown that we don't know yet, right? And so when we take 1/3 minus 1/7, now remember, anytime you add or subtract fractions, we have to have a common denominator. And so the common denominator between 3 and 7 is going to be 21. So how do I write 1/3 out of 21? Well, that's 7/21 minus, and now this is going to be 3/21, which is equal to 4/21, okay, times some x has to equal one full container. And so when we divide, or remember how we divide fractions is multiplying by the reciprocal, 21/4, right? And 21/4, we find that it's going to take 21/4 minutes to fill that. And so x is going to equal 21 divided by 4 would be 5 and 1/4 minutes. So think about it. If it fills in 3 minutes and it drains out in 7 minutes, at the same rate, it's going to take 1 1/4 minutes to fill if the spigot is wide open. Okay? So what is a work problem? Well, work is this. It's rate times time equals work. Or in our case, whatever we're doing times whatever we're doing, our work is always going to equal 1, right? And that's kind of the beauty of it, okay? So here's an example. It says Jack can paint a wall in 3 hours, and John can do the same job in 5 hours. How long will it take if they work together? Okay, so think about it. We want it to equal one job done, right? So let's take a look at it. So here's Jack. Jack can paint one wall in 3 hours, right? And John can paint one wall in 5 hours. And looking back at our equation, it said our rate times time. Okay, so we don't know the time. That's what's our unknown in this case. So our time is x or y or whatever. And we said our work is always going to equal 1. So think about it. 1/3 plus 1/5 times some x has to equal 1. So what we're going to do is we're going to simplify. And we're going to say, well, what is 1/3 plus 1/5? Well, with a common denominator, they both turn into 15. So this is 5/15 plus 3/15, which would be 8/15 times some x has to equal 1. Obviously, doing the reciprocal, we find that x is equal to 15/8, which would be, 8, which would be 1 7/8 hours. So does it make sense that if Jack does it in 3 hours, John does it in 5 hours, that it would take them less than 2 hours to work together? All right, let's take a look at another example. This one's interesting because we actually don't know one of the unknowns or one of the rates. It says, working together, painter A and painter B would finish a task in 24 minutes. Printer A alone would finish a task in 60 minutes. How many pages does the task contain if the printer B prints 5 pages a minute more than printer A? Okay, so let's think about this. Let's think about the problem. All right, so together they work in 24 minutes. So let's write that down. We're going to say A plus B is 24 minutes, right? And it says A is 60 minutes. Okay, so A is 60 minutes. And it says how many pages does the task contain if printer B prints 5 pages a minute more than printer A? So if we think of B is really A plus 5 pages, right? Okay, um, so let's take a look at our rates, right? So A is going to be 1 page in 60 minutes, right? B is going to be 1 plus 5 pages, so 6 pages in 60 minutes. And together times the rate is going to be 24 minutes. Okay, so let's put that down, okay? So A is 1 page in 60 minutes, right? 1 page in 60 minutes, or 1 job in 60 minutes. Plus, the next one would be 1 plus 5, which would be 6 in 60 minutes, times some rate, x, is going to equal 24. And so when we add these, notice, check it out, they have the same thing. So it's going to be 7 over 60 times x is going to equal 24, right? So what we can do is we can multiply by the reciprocal, or 60 over 7, okay? We find that x is going to equal, well, let's use a calculator for that. So 24 times 60, right, divided by 7 equals 205.7. Okay? All right, example 3. A group of 5 craftsmen working together at the same rate can finish a job in 3 hours. How long would it take a group of 4 apprentices working together to do the same job? Okay? So a group of 5 craftsmen working together at the same rate can finish a job in 3 hours. Okay, so remember, rate times time equals work, and our work is always going to equal 1. So, so we know in this case that our time for our first example is going to equal 3 hours, right? 3 hours. All right, so, and we don't know what how fast each craftsman is going to go, right? The 5 craftsmen. So I'm going to say 1 over c plus 1 over c plus 1 over c plus 1 over c plus 1 over c, right? There's the 1, 2, 3, 4, 5 craftsmen, right? 5 of them, times the time, which would be 3, is going to equal 1, right? Our work. Now, obviously, you can add these up, and it's a little bit easier. 1c plus 1c ends up being, you'll notice, it's 5 over c times 3 equals 1. And so we get 15 over c equals 1. So c is equal to 15. Now it says, right here, how long would it take a group of 4 apprentices to work together to do the same job? Well, we know that that's 15, right? And so we'd say 1 over 15 plus 1 over 15 plus 1 over 15 plus 1 over 15, right? Times the time, which we don't know, x equals 1. And so we'd get 4 over 15 times x equals 1. Okay, we multiply by the reciprocal, 15 over 4, right? and that would just be 15 over 4. And so what is 15 over 4? It's going to be 3.75 hours. So think about it. If 5 of them take 3 hours, would it make sense that 4 of them would take longer? I think that does make sense. Okay. So let me know if you have any questions after doing this, and hopefully these work problems are not too difficult for you, but if they are, just let me know. Have a great day.